Hello everyone. Section 1.2, measuring and constructing segments. Do your definitions. When you get to the postulates and theorems, you want to fill these in. I've left you space to fill in all the information that you can get from our textbook. As I slide up here, we have example 1. Find the length of segment XY. Notice the notation. That means find the length of segment XY. So we can do this using the ruler postulate or by counting our spaces. From X to Y we have 1, 2, 3, 4 spaces. So the length of segment XY is 4. The length of segment XZ, 1, 2, 3, 4, 5, 6, 7. XZ has a length of 7. XW, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. YZ, 1, 2, 3. YW, 1, 2, 3, 4, 5, 6, 7. And ZW, 1, 2, 3, 4. That's example 1. At the bottom here, you'll see we have instructions for copying a segment. It's our first construction. I've already created a video for how to do these constructions. This is construction number 1. For information on how to do this construction, you can read these instructions and you should follow the video that's up on this YouTube site, and it'll also be on Google Classroom. We're going to use this construction in a minute, but you want to familiarize yourself by watching the construction number 1 video. Alright, example number 2. Which segments in example 1 are congruent? So if I flip back here to example 1, which ones are congruent? Well, which ones have the exact same lengths? Scroll it up a little bit. Which ones have exact same lengths? We can see XY and ZW have the same length. Segment XY is congruent to segment ZW. And again, notice I'm using proper notation, which you can read about up above. Segments are congruent. Lengths are equal. Okay, and the question's asking us for congruent segments, so I have to use proper notation. There's another pair here. We have segment XZ and segment YW have the same length. So segment XZ is congruent to segment YW. And there's our answer to example 2. Example 3. We're going to plot these 4 points, and then we're going to determine whether segment PQ and RS are congruent. So, point P is at -4, 3. There's point P. Point Q is at 3, 3. So there's segment PQ. Segment RS, point R is at -1, 4. And point S is at -1, -2. There's segment RS. And how do we determine if these two segments are congruent? We determine to see if they're congruent by counting or by finding their lengths. So the length of PQ, 1, 2, 3, 4, 5, 6, 7 spaces. The length of PQ is 7. The length of RS, 1, 2, 3, 4, 5, 6. So these two segments are not congruent. We cannot make a congruent statement. Right. Moving on. Define the word between and fill in the segment addition postulate. Segment addition postulate is talking about adding two smaller segments and getting a bigger segment, as long as they're collinear. Okay. Example 4 is where we're going to use construction number 1 and the segment addition postulate to add these two segments together. We're going to first copy them. We're going to add them. In addition to adding the segments, we're going to be able to subtract them, multiply them, subtract them, add them, multiply them, and do all sorts of other different things. So let's start off with part A. I'm going to need a line which to work off of. So here I have a line, and I need to make a copy of segment A on this line. So we're going to start with a point here. And that's going to be my center of rotation that I'm going to use. I need to set the length of my compass to the length of segment A. Put my center of rotation on this point here. Make my arc. And this is a copy of segment A. And off of that, I need to make a copy of segment B, so that I have added these together. There we go. Set my length to the length of B. Reset my radius. Make my arc. This is B. And now this segment here, from here to here, is A plus B. Now we're going to do part B, which is B minus A. So again, I'm going to start with a line. And again, I'm going to make a copy of B. This should still be set to the length of B. And it is. I need a point to start from. We're going to make a copy of B. So this is B. And then from either here or here, I need to make a copy of A. Mark over here. Set my length, the length of A. And I'm going to do it from the left side. I could do it from the right side, really doesn't matter. I'm going to do it from the left side. So this is the length of A, which means that when I do my subtraction, this segment here is B minus A. And that's the answer to part B. Let's do part C now. We'll make a fairly decent sized one here. I might need to make it bigger. We'll see. Let's go a little bit bigger. There's my line. Again, we need a starting point. I should still be set to the length of A. I just like to check. And so I'm going to make 3 copies of A. There's one. There's 2. This is why I made it a little bit longer. Good thing I did. There's 3. And now I need to subtract my B. So let's set the length of B. Yeah. Perfect. And I'm actually going to go from, so this is from here to here is 3A. I'm going to go from the right hand side. I could go from the left hand side, doesn't matter. But I'm going to go from the far right hand side here. This is B from here to here. So that means that this right here is 3A minus B. And that goes from here to here. Alright, our last one. A plus 2B. This one's going to need to be big. So I'm going to make this longer than what we've done so far. There we go. Alright, let's make our copy of A. And our starting point. Here's our copy of A. There's A. Now I need 2 copies of B. Set my length here. Actually, I'll do it in that one. One. This is B. And did I make it long enough? Oh, I did. Just barely. Second B. Making this A plus 2B. All the way from here to here. Let me highlight that. So this is my A plus 2B. So that's example 4. Let's move on. Well, I was afraid this was going to happen. I probably shouldn't have made this two-sided. That's all right. Example 5. Find the length of segment XZ. Well, xz is from here to here. xy is 14. yz is 27. Add those together, and the length of segment xz is 41. Segment addition postulate. Find the length of CD. Well, CD is BD minus BC. CD is 25 minus 19, or 6. Okay. Part C, we don't have a diagram, but we can make one. Point T, and this is why we had to define this word, point T is between X and Z. So we're off to the side here. Do a quick sketch. Here's X. Here's Z. I'm going to make T in between X and Z. XT is 12. XZ is 21. What's the length of TZ? So it's segment addition postulate, but we subtract 21 minus 12 to get the length of TZ. TZ equals 9. Okay. Take a look at part D here. AB equals 25. Find the value of X. Here we have an X here. We have another expression here that has an X. After we find the value of X, we're going to find the length of AN and the length of NB. Let's start off finding the length of, or the value of X. To find the value of X, we need to know that AN, segment AN, plus segment NB equals segment AB. Let's write that out. The measure of segment AN plus the measure of segment NB equals the measure of segment AB. Well, what's the measure of segment AN? The measure of segment AN is 2x minus 6 plus the measure of segment NB is x plus 7. And that has to equal the measure of segment AB, which we're told in the problem is 25. A little bit of algebra. 3x plus 1 equals 25. 3x equals 24. X equals 8. So we have found the value of X. Now we've got to find the length of segment AN and the length of segment NB. We do that by plugging our X back in. 2 times X is 16 minus 6 gives me AN equal to 10. Now I can find NB two different ways. I can plug X, my value of X, in here. 8 plus 7 is 15. Or I can say AB is 25, AN is 10. What's left to get me to 25 is again 15. NB equals 15. And there are our 3 answers for part D. Part E. If T is between X and Z, and then we have some expressions here, we're going to find the measure of segment XZ. So, again, I'm going to draw a picture. Let's see. XZ is 3 times X. XT is X plus. Okay. So here's X. Here's Z. And let's put T over here. So XZ is 3X. XT is X plus 3. TZ is 13. we want to find the length of segment xt. So again, segment addition postulate. And what segment addition equation can we write out? Well, we can say xt, measure of segment xt, plus the measure of segment tz equals the measure of segment xz. Xt is x plus 3 plus tz, which is 13, equals xz, which is 3x. Again, a little bit of algebra. X plus 16 equals 3x. 16 equals 2x. X equals 8. And if x equals 8, then xz, which is 3x, xz equals 24. And there's part E. Example 6. On ray AB, how many points are there whose distance from B is 10 centimeters? This is a little tricky question because there isn't one answer. The answer varies. The answer depends. How far away is B from the starting point or end point A? If how many points are the distance from B is 10 centimeters. If the measure of segment AB is less than 10 centimeters, then there is 1 point (10 centimeters) from B. And I'm going to illustrate this in a second. If measure of segment AB is greater than or equal to, greater than or equal to 10 centimeters, then there are 2 points 10 centimeters from point B. So I'm going to illustrate that on this piece of paper here. I'm going to draw ray AB. I'm going to draw 2 different rays AB, and actually I'm going to use centimeters. So here's A, and let me illustrate AB being less than 10 centimeters. Here's B. Now, how many points are 10 centimeters away from B? Actually, I'm going to make it smaller. Let's put B over here. 10 centimeters away from B is right here. If I go 10 centimeters to the other side, first of all, I'm off the paper, but if I go 10 centimeters to the other side, puts me right here, there's no ray over here. The ray doesn't exist to the left of point A here. So there's only one point when AB, length of AB, is less than 10 centimeters. But if the length of AB is bigger than 10 centimeters, and this is going to be tricky to illustrate. I'm actually going to not use the centimeter scale this time. So let's say this was, what did I make this? This was 2 centimeters. This is A. I'm going to put B here. And I'm going to call this 15 centimeters, even though it's not in reality. I'm just going to say it's 15 centimeters. Okay. That means that at 10 centimeters away, there's a point here and a point here, 10 centimeters away, giving me 1, 2 points 10 centimeters away from point B. And it all depended on the length of AB. That's why our answer had multiple parts to it. So, we have one last question here, example 7. Write an inequality whose graph is described. All points on ray MY that are not on ray NG. Well, ray MY starts here and goes to the right. Ray NG starts here and goes to the left. So what are the points that are on MY but not on NG? Well, they start here at N, but they can't include N. They start here at N, but they can't include N, because that would be on ray NG. So, and they go to the right. So what inequality describes that? Well, that's all the points x greater than, but not greater than or equal to, just greater than 2. That means all the points that start here at 2, and if you think back to your Algebra 1 days, that would be an open circle at 2 and to the right. And that's this inequality. And that is section 1.2. Thank you very much.